Hello there, welcome back to another class. We are continuing with the indices, and our previous class we did look at more questions on indices, different approach that we can have, and we did look at question number 1 and 2, and now I would like us to look at question number 3 and question number 4, just to see different ways of asking questions on indices and then how we approach them. So on the board I have the two questions, number 3 and 4, and I'd like us to start with number 3. So we have 49 power x plus 1 plus 7 power 2x is equals to 350. This question is a bit similar to the question number 2, where you can see that we have addition sign in our numbers there. Of course, 49 and 7, you can have them having the same base, that is base 7, but 350, of course, we cannot have it into the base of 7 because 350 is 50 times 7, not 7 power in the number here. So in this case, we are going to have it an approach like the way we have done number 2, where we can write 49 into the base of 7, where we're going to be having at 49 is the same as 7 squared, or 7 power 2, then power x plus 1 plus 7 power 2x is equals to 350. And it's like that. You can open this brackets here. You have 7 power 2x, 2 times x, 2x, 2 times 1 plus 2 plus 7 power 2x is equals to 350. Now, when you look at 7 power 2x plus 2 and then plus 7 power 2x here, I want us to use the same approach here, where our law number 1 for indices is a power m times a power n is equals to a power m plus n. So we have 7 squared, 7 power 2x plus 2 as is in this format, a times a power m plus n. This is now our 7 power 2x plus 2. I want us to go back. Where did you get to come to this? And you go back to this form now. It's going to be 7 power 2x then times 7 power 2. So here you can have it as 7 power 2x plus 2. You can write it as 7 power 2x times 7 power 2. Then I add 7 power 2x there is going to give us 350. And you can be able to say that we have 7 power 2x, 7 power 2x there being the same. Now, we can say let 7 power 2x be a number like m, because you can be able to say that we have 7 power 2x, we have 7 power 2x there. So if it is our m now, we come and replace it there. Now you're going to be having 7 squared times m plus m is equals to 350. And then this is 7 squared is 49m plus m is equals to 350. This is 49 plus 1, that is 50m is equals to 350. And divide by 50 on both sides and have m is equals to 7. So here we had gotten m using a different approach of the same of that question. Now our m now was 7 power 2x. So we replace that. 7 power 2x is equals to our m here is 7, and of course 7 is just 7 to the power 1, meaning now that the bases are the same, also the powers are the same. So 2x is equals to 1, and then x will be divided by 2 on both sides, 1 over 2, simply a half. So that is another approach of solving that kind of a question. Whenever you have addition sign, you have to be keen because we don't have the law of indices on that case. So you have to solve that question using a different approach like the one we have done. Good. Let's look at question number 4. We have to simplify fifth root of 32 y power 10k power 15 and 2 power 10 is divided by fourth root of 16 y power 12k power 16 and then 2 power 4. So in this case we can first write that 2 and 16 into the base of 2, and of course we know that the square root, we had the row number 5 for the indices, where we said that for the fraction part, we said an example here that a power 1 over n, this is simply the nth root of a. Meaning now, if you have the fifth root here, we can simply go back to this case here. If we are 1 over a power 1 over 5, this is the same as what? The fifth root. So of a. So we can simply go back to that format and write the fifth root and the fourth root in terms of the fraction. Let's do it. So that 2 there, of course, that is 2 power 5. Then y power 10 and k power 15, and then another 2 power 10. Everything into bracket. I changed the fifth root in I write it into index form, and this is going to be 1 over 5 all over 16, that is 2 power 4, and then y power 12, and then k power 16, and the 2 power 4, all of them is fourth root. So fourth root, I write it as per 1 over 4. And then I can open the bracket. I multiply everything by power a fifth on the numerator. So 2 power 5 times a fifth, I'm going to be having 5 divided by 5 and get 1, so it is going to be 2 power 1. Then y power 10 times a fifth. So 10 times a fifth is going to be, by 5 1 by 5, 2. So it's going to be y power 2. And then k power 15. So 15 times a fifth is going to be by 5 1 by 5, 3. So it's going to be k power 3. And then you have this 2 power 10 times a fifth. So by 5 1 by 5, 2. So 2 power 2 all over the fourth root, of course, is power quarter. So 2 power 4 times a quarter. So by 4 by 4 1 you get 2 power 1. And then y power 12 times a quarter there, you get a quarter times 12, that of course is going to be 3, y power 3. And then k power 16 times a quarter. So 16 times a quarter, that is going to be k power 4. And the 2 power 4 times a quarter, of course, 4 times a quarter will be 2 power 1. And we can have the numerator there. When you look at it, we have 2 power 1, 2 power 1. This one can cancel. Then you're going to be left with y squared k power 3, 2 power 2, and then divided by y cubed k power 4, the 2 power 1. And then in this case, you can just have the y there. We have in the numerator y squared. Remember, indices we look at the numbers that have the same base. So we have y squared in the numerator and the y cubed in the denominator. So when we are dividing, we subtract the power. So 2 minus 3, and then k. In the numerator, we have k power 3 divided by k power 4. So we get 3 minus 4. And then lastly, we have 2 power 2. Then we divide by 2 power 1. So we subtract the power 2 minus 1. In this case, it's good to have what? Y 2 minus 3. That is 2 minus 3 is minus 1. And then 3 minus 4, k will be minus 1 also. 3 minus 4 is minus 1. And then 2 per 2 minus 1 is 1. So that is our answer there. Or else we can write it in a different way, where the y per minus 1 and k per minus 1 there, you know, the minus means the reciprocal. In other words, if you want it to be positive, we write it on the other side. They are in numerator, we write them in the denominator. If they are in the denominator and we want to change the sign, we put them on the upper side. So we are going to be having 2 all over y times k. So the two answers are the same. So that's different questions that you can have on indices. Thank you very much for your time.